Welcome to Edivon. For over 30 years, we have provided premier technical teaching equipment across the globe. Our product range covers most technical areas, which include engineering physics, electronics, communication, and renewable energy. Every Edivon product is designed, manufactured, and quality controlled at our headquarters in Madrid, Spain, under several quality standards.
In this video, I will explain the computer-controlled liquid mass transfer unit coefficient, QDTLC. The QDTLC is a didactic teaching unit that allows the study in depth of notion of mass transfer theory, specifically the diffusion in liquid systems.
The computer-controlled liquid mass transfer and diffusion unit coefficient consists of a small volume tube with a filtering cell that has a certain number of pores at one of its ends. A concentration solution of salt, sodium chloride, needs to be poured inside, and then the tube is introduced in a vessel with pure solvent, in this case distilled water. Once this is done, the diffusion process starts and it will be indirectly measured by the conductivity data. A thermostatic bath allows the performance of experiments at different temperatures. The QDTLC unit allows to obtain data and experimental results of the practical processes. This unit is supplied with a SCADA computer control system, which is patented by Edivon and based on LabVIEW. The system includes the physical unit, the control interface box, a national instrument data acquisition board, and a software package that allows computer control, data acquisition, and data management. QDTLC main components. Number 1. Tank. This is a transparent tank designed for liquids, divided in two parts. One is the experimentation vessel, and the other one is the thermostatic bath. This tank has a capacity of 2.5 liters. Number 2. Magnetic stirrer and magnet. This magnetic stirrer is a computer-controlled element, and it has a capacity range going from 0 to 300 RPM. This stirrer will be controlling the magnet while the experiment is being performed. Conductimeter. This device will be measuring the conductivity values through the performance of the experiments. It also provides fast and accurate readings. Conductivity sensor and cell. These components will measure the conductivity, that is the capacity of a solution to conduct electric current. These have a measuring capacity of 0.1 milliseconds to 19.99 milliseconds, a resolution of 0.1 milliseconds, and an accuracy of plus or minus 2%. The diffusion cell or sensor has capillary numbers of 317, a capillary length of 5 mm, and a capillary diameter of 1 mm. Number 5. Experiment vessel. This is the left part of the tank. Here is where the experiment will be performed. The filtering cell, the conductivity cell, the conductivity sensor, and the temperature sensor are located here as well. Number 6. Thermostatic bath. The thermostatic bath is located on the right side of the tank, with a water capacity of 8 liters and a heating resistance of 500 watts. This is computer controlled. The level switch and the temperature sensor, with a range of -40 to 750 Celsius degrees, are located here. Number 7. Resistance element. Like mentioned before, this unit has a heating resistance of 500 watts. Because the conductivity of a solution increases with temperature, this is a very important element. Number 8. Level switch. This component is in charge to detect the water level in the thermostatic bath. Therefore, if there is no water, the level switch won't allow the equipment to turn on the resistance element to avoid overheating. Number 9. Temperature sensors. As mentioned before, this unit has temperature sensors with a range of -40 to 750 Celsius degrees, allowing the performance of diverse experiments. Number 10. Control interface. The control interface has a process diagram in the front panel with the same distribution of the elements located in the unit. This component allows the storage of all process data and results with real-time curves representations. Like most Edivon's units, this one also has 3 safety levels, one mechanical, an electronic one, and another in the control software. Here is a representation of the parameters the control interface has. ST1 and ST2 are the temperature sensors. AN1 is the level switch, and SCC1 is the conductimeter sensor. Main components layout. Here is a representation with the QDTLC's main components layout, showing the conductivity cell, the diffusion cell, the stirrer, the experimentation vessel, the thermostatic bath, the resistance element, the temperature sensors, and the level switch, one by one. QDTLC process diagram and elements allocation. This diagram shows how the 3 actuators and the 3 sensors are controlled from the computer and how this works simultaneously.
We are going to perform practice number 1, application of fixed law for the determination of diffusivity. First, you're going to prepare a solution of 300 milliliters of water and half of a mole of salt. Once you're done, you're going to pour it into the diffusion cell. Make sure to clean up any excess of water outside of the cell.
Fill the thermostatic bath with water until the water reaches the level switch component.
After you fill up the tank to the level switch, you are going to turn on the stirrer for the magnetic device that is down here that is going to help us to do the experiment. Once that is done, you are going to start the software and begin the experiment. You're going to click start. You're going to set the temperature of the resistance that is down here to 20. And you're going to check the mark that says PID on AR1 ST1 set point. Click start. Choose graph A, ST1, ST2, SCC1, and now you have to wait a couple hours for the experiment to be done. To begin your experiment, click Start and choose where you want to save your data and results. Then click OK. Temperature sensors are located in the upper right side of the software. Turn on all the actuators located at the bottom left of the screen. Click on ST1, ST2, SCC1 to get a graphical representation.
Change the temperature to 35 degrees. After you decide you have enough data collected, click Stop. Then View Data and choose the file you saved at the beginning of the experiment. A graph screen will appear. Choose the parameters you want to represent in your graph and adjust the colors if needed. You can click Auto Scale, or you can choose the scale you desire for a better visualization. I have chosen -5 and 35 for the scales. Press the close button and then press Done. And lastly, click the Quit button, and this way you will be finalizing your experiment. The user manual provides multiple practical exercises that walk the student through the correct operational procedure while teaching specific concepts. Possibilities of other available expansions. Mini ESN multi-post Erivan Miniscata net system that allows 30 students to work simultaneously with one central computer in one unit. ESN multi-post Erivan SCADA net system that allows 30 students to work simultaneously with different units in just one central computer. Only Erivan has a SCADA system that provides the following benefits: open control, multi-control, and real-time control. This means that at any time during the experiment, multiple parameters can be changed at the same time with instantaneous effect on the unit. Each unit has specialized Erivan control software based on LabVIEW to enable AC control of the unit. Calibration exercises which are included teaches the user how to calibrate a sensor and the importance of checking the accuracy of the sensors before taking measurements. Projector and electronic whiteboard compatibility allows a unit to be explained and demonstrated to an entire class at one time. The system is capable of being remotely controlled over the internet by the user or by an Edivon technical support engineer. Each unit has 4 safety systems that are designed to mitigate risks for the user. This unit has been designed for future expansion, such as incorporate in the unit an Edivon SCADA-net system, which enables many students to simultaneously operate any unit in their SCADA network. Dimensions and weights. QDTLC unit. Dimensions 500 by 370 by 500 millimeters approximately. Weight 20 kilograms approximately. Control interface box. Dimensions 490 by 330 by 310 millimeters approximately. Weight 10 kilograms approximately. PLC module. Dimensions 490 by 330 by 310 millimeters approximately. Weight 30 kilograms approximately. The following is included with every Edivon unit. 8 manuals including a user manual that explains the scientific theory being studied, any related mathematical equations, the function of each component in the unit, and how the unit is operated. Each unit is designed and manufactured under strict quality control, which allows to offer a 3-year guarantee against any manufacturing defect and components controlled during the lifetime of the unit. Lastly, due to the previous cited points, Edivon proudly provides full customer satisfaction. Thank you for watching this video. A link to our website can be found in the video description below. For more information, please contact us by phone or email. We look forward to talking with you.